So today we're going to be learning about the sine, cosine, and tangent ratios. Yet again, we're still dealing with right triangles. So Pythagorean theorem still applies, all our special right triangle rules still apply. We are just going to be learning some other rules. Pythagorean theorem, we said, was limited to the fact that you have to have two sides in order to find the third side. And we said that we had some special right triangles that we could kind of cheat and jump straight there, still based off of the Pythagorean theorem. But trig, that's what this is, sine, cosine, and tangent, is getting into trigonometry, not geometry, but trigonometry. And it will allow us to do things when we just have one side of a triangle, if we know something about its angles. And what it deals with is ratios. Don't forget what ratio means. Ratio just means a fraction. So we're talking about dealing with fractions and proportions and all of that kind of stuff, which we used a little bit this unit already. So these are all some things that you're familiar with. So we need to talk about some vocabulary. You guys are already aware that the side across from the right angle, opposite of the right angle, is called the hypotenuse. It's always the longest side of the right triangle. So we have the hypotenuse of a right triangle. And we called the other two sides legs. What I want to talk about today is that we can talk about the legs of a right triangle with respect to a particular angle. So for example, with respect to angle B, if we're looking at angle B, the side opposite of angle B is going to be over here, AC. Okay, it would be opposite of angle B, okay, which would make this side right here, AB, adjacent to side B, okay? So this would be the adjacent side to angle B, and this would be the opposite side to angle B. Now, the good news is the hypotenuse is always the hypotenuse. It's not going to change. If, however, we look from angle C's perspective, the side that's opposite it is going to be over here. This is going to be the opposite side. And the side that is adjacent, from English, you guys know the word adjacent means right next to. And so the side right next to angle C, in fact, it's part of angle C, AC, would be the adjacent side to angle C. So notice the adjacent and opposite side depends on which angle you're dealing with. Hypotenuse never change. Hypotenuse is always the hypotenuse. So let's take a look at an example. Okay. So if we have angle E, angle F, and angle G, and I were to ask you to label the sides with respect to angle G, okay, label the sides with respect to angle G, then we would look at angle G and say, okay, here's angle G. I know the hypotenuse is always the longest side, the one across from the right angle. So this is going to be the hypotenuse. I'm just going to use an H for the hypotenuse. The opposite side is always directly across. It's kind of like, what is the Pac-Man eating? So directly across from angle G would be my opposite side. And then the side that actually touches angle G is going to be my adjacent side. And so we have our opposite side, our adjacent side, and our hypotenuse side. Why is Miss Parker spending so much time labeling sides of a triangle? Opposite, adjacent, hypotenuse. They're just vocabulary words. Who cares? All right. Obviously, they're important. These are the vocabulary words that we use to identify the trig ratios, sine, cosine, and tangent. You have to be able to identify these correctly, or you can't actually find the sine, the cosine, and the tangent. All right? So what is sine, cosine, and tangent? Sine, cosine, and tangent are just ratios using the sides of a right triangle. Okay? You may have seen these buttons on your calculator before. Sine is abbreviated S-I-N. It is not sin. Do not say sin. It is the abbreviation for sine. And it is the sine ratio. Now, we find sine, cosine, and tangent of angles. So I would say something along the lines of what would be the sine of angle C, or the sine of angle B, or the sine of angle A, the cosine of C, or the tangent of B. All right? So inside the sine, there's always going to be an angle here. You may see on your calculator, if we have the sine of 45 degrees, we can actually go to our calculator. Let me get my calculator up here so that we can take a look at it. We can go to our calculator, and we can just type in sine. You'll notice sine, cosine, and tangent, S-I-N, C-O-S-T-A-N, are buttons right here on your calculator. So if we type in sine of 45 degrees and hit enter, it will give us a decimal. Now, it will not give us the fraction. It will not give us the ratio, but we can get an approximation using our calculator. If we want to say cosine of 52 degrees, we can just type that into our calculator. You can get positive and negative numbers. That's fine. Tangent of 102 degrees is not going to be possible. So let's try tangent of 85 degrees. Here we go. We can do that. All right. So these are all buttons on your calculator. You can do that. And then, so that's just how you type things into your calculator. But how do we find them if we don't happen to know the angles? It's just a ratio. So this is what you need to know. The sine ratio is equal to the opposite side over the hypotenuse. The cosine ratio is equal to the adjacent side over the hypotenuse. And the tangent ratio is equal to the opposite side over the adjacent side. All right? And so you're just going to end up with a bunch of different little fractions that follow along this. It's really super easy. If, for example, we know that this side is equal to 3, this side is equal to 4, and this side is equal to 5, we can then find the sine, cosine, and tangent for any of these angles. So let's say that we want to find the sine of angle C. All right, the sine of angle C. That means I want it with respect to this angle. So first I have to determine what's the opposite, what's the adjacent, and what's the hypotenuse. So I know this is the hypotenuse. It's going to always be the hypotenuse. This is C, so opposite, I've got to come straight across. This is going to be my opposite side. And then this one touches C, so it must be my adjacent side. So if I'm looking for the sine of C, sine is opposite over hypotenuse. So the opposite is 4. The hypotenuse is 5. So the sine of angle C is equal to 4/5. How about I want to find the cosine of angle C? Well, cosine is equal to the adjacent over the hypotenuse. So the adjacent is 3, and the hypotenuse is 5. So that would be what the cosine of C would be equal to. And then the tangent of angle C would then be the opposite over the adjacent. The opposite was 4, and the adjacent was 3. And so that would be the tangent of C. Do notice, if you change your perspective, we change our angle, and we want to find the sine of angle B. It's the same triangle, but we're going to get a different answer. Because for angle B, this is the opposite, and this is the adjacent. So for angle B, my opposite over hypotenuse is actually going to be 3/5. Okay? So it is very important that you realize which one is the opposite and which one is the adjacent for that particular angle. It changes depending on which angle you are dealing with. But you can find the sine, the cosine, and the tangent as long as you know what the 3 sides are. Don't forget the Pythagorean theorem. If you only know 2 of the sides, you can still find that 3rd side using the Pythagorean theorem. But these are the sine, cosine, and tangent ratios.